Hello and welcome to the Environmental Test and Design webinar. RFQ, Now What? Part 2, Procedure Development. For Military Standard 810, Understand Your Requirements for Military Equipment. My name is Belinda Stachukevich and I'm the editor of Environmental Test and Design. Environmental Test and Design, which launched in 2009, specializes in the interrelationship between electronic systems and devices and their environments. This webinar is presented by Steve Ferguson, Executive Vice President of Washington Laboratories. Steve has worked in the compliance test arena for over 35 years at test labs and manufacturing companies, designing products, developing procedures, and performing tests. He presents various courses on EMI and EMC compliance. He's an INARTE certified EMC engineer and administers the INARTE-approved Washington Laboratories Testing Center. This webinar is part 2 in a series on RFQ, Now What? Mil Standard 810. Watch part 1 on our website, environmentaltestanddesign.com. This webinar will be interactive. You will be able to ask questions and answer polls, and we encourage you to participate. Take a look at the GoToWebinar navigation pane. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or report an issue, click the hand icon. We will present the topic for 45 minutes, followed by a 15-minute question and answer session. Before we begin, we have a poll for our audience. Attendees, please answer the following question. What role do you have in environmental testing? Developing standards, product design, test and evaluation, or other? We'll give you a few seconds to answer. We have some answers coming in, and the majority are in test and evaluation. Now Steve will begin the presentation.
Well, good afternoon, and thanks for attending. I look forward to discussing this topic and hope everyone gains some insight. And by all means, ask questions. It does help. You indicated that the majority of people attending work in the test and evaluation group, and I'm sure most attendees will realize that what we're talking about here is often omitted during their roles. They end up doing tests without having anything like this, and quite a few test people involved in getting the things to happen. So what I wanted to do was just kind of open the subject matter up and discuss it. A plan versus procedure. I like to think there is a distinguishing difference between the two, where the plan is an overall evaluation approach, something to decide how I'm going to accomplish the evaluation. It involves test, inspection, and analysis. Is the typical things, but can take on many ways. The analysis has many forms. It can also be done and considered as analysis to take prior tests. For example, a fungus test may use materials that is pre-qualified. So the analysis would simply indicate a pre-qualified item, refer to those pieces of information to accomplish the evaluation and determine that it complies or fails to comply if as appropriate, or determines that we need to investigate further. So the plan is the top-level parent document. It's derived and comes up with the life cycle phase of your environmental development. I forgot the task number off the top of my head. I think it's 404. But all these things are derived from those things where the life cycle has been evaluated. Hopefully that's the case that drives your particular pieces. A procedure becomes more like a step-by-step instruction set. It provides items on the test, details on the test item, like how are you going to configure it? What are you going to make happen? Acceptance criteria and exceptions and deviations. We'll be discussing those things in more detail as we proceed. But in general, the procedure is step-by-step. Now, a step-by-step procedure can go beyond just the test. Most people think test procedure. but it could involve the modeling and simulation, calculations, inspection criteria. What's acceptance during inspection? Are there holes allowed or not? Various topics can be discussed in your overall procedure. So it's not limited to tests, but for our discussion today, we're going to think tests, that the plan has been taken care of and we are the test lab executing the test. The data item descriptions, the DIDs as we call them in the military, are definitions of what's to be contained in the document that it's describing, the data item. I don't have a lot of DIDs associated with Mill Standard 810. In 810 there's no reference to a particular DID except for shipboard vibration. And in there they get really detailed about the product and its application, including what type ship, what serial number. Various topics deal with on qualifying a product for shipboard activities, so we can have the specifics. But some people look at Mill Standard 810 as a procedure document. In reality it's not. It comes from Task 405, where the test plan is developed, the detailed environmental plan, and it calls for preparation based on this Task 404, the environmental issues criteria list results. It includes laboratory tests and field trials, details on the execution of various test methods, but does not include specific method details. So there's a lot left out if somebody says, oh, I'll just do the test according to Mill Standard 810. It requires much more definition, and blindly taking all the criteria of Mill Standard 810 is a severe impediment to getting a realistic test accomplished. It's almost impossible to do the worst case for all these events. But basically it does not call or define the test procedure content. So for our purposes, oh, I've got another question.
We'd like to ask a poll question for the audience. Do you have test procedures developed by Design Engineering Test, Test Department, Designated Contracted Test Laboratory, Contracted Consultant, or other? We'll give you a few seconds to answer. We have some answers coming in. And small majority said Test Department, followed by Design Engineering Test, and then other.
Okay. Well, all of these topics are used. The design people, quite frankly, have knowledge of the product. They should be designing it to meet a contract requirement or some other application requirement based on the customer and integration plan, something to tell us how we're pulling this together. Quite frankly, the test department gets involved a majority of the time and usually rely on direct contact with the design engineering group to come up with what is the unit, what's its application, etc. But the test department has familiarity with how to do a test. So they pull the procedures together very nicely, but they don't do it without a lot of product data from the design group. Contracted test laboratories are used quite often, so they can, or I've already determined who's going to do the test. And especially smaller companies do not have the test department or people that are used to dealing with procedure work. So they go to the contracted laboratory as part of the overall program that they're going to have accomplished by a selected laboratory. Contracted consultants are used quite freely, shall we say, somebody specializing in that type of product that are used to what requirements are, and basically they're professional writers with the knowledge of how to do it. They're hard to beat on pricing, etc., to develop a test procedure. And other can be anything. But in general, a lot of folks are starting to look at these contracted consultants because they realize how many man-hours internally it takes to develop a procedure without the detailed expertise on board. Larger companies do have those people aboard. So in general, everything is used, but I see the test department frequency So since Mill Standard 810 didn't quite give us the detail of it, let's develop something here. What do we need to consider in the test procedure? Now this outline is derived from the Mill Standard 461 world, where the DIDs are very, very specific. They call for these things. Now it's not exact because we need to adjust it for this type product, but in general this concept follows. I've used it many times in developing procedures for EMC, environmental, and other topics, power quality, you name it. And the concepts work where we deal with this. So each one of these topics I will go through as part of the detail that we're going to mention today. The introduction, what are we going to do, description of the test article, any references, how are we satisfying the contract callouts, locations and instrumentation, how are we going to configure the unit and how are we going to operate it. And then the step-by-step, blow-by-blow details on every one of the individual tests and any deviations from those things that we talked about in the early part of the plan, like the configuration or operation. So let's just jump right into it. Introduction defines the scope. Is this scope going to be an all-inclusive document that takes care of environmental things throughout the world? Is it going to include the inspection and analysis work? What details are we going to go for? What are we trying to accomplish in preparing this? We need to define which tests are going to happen, the specific methods, something as a top-level view that says these things will be evaluated according to what? The applicable standards should be involved in this. Which tests? Am I going to do everything according to Mill Standard 810? Or am I going to integrate things from my EC 60068 or DO160 or various other environmental test standards for specific applications? Sometimes it's a combination of various events, especially when we're trying to develop a product that has widespread applications, vehicles, aircraft, ships, ground facilities, almost anything, space applications. But always, if Task 404 has been defined or those detailed requirements are out there, we need to address each one of those topics for sure. Contract information, where is it coming from? Is it an Army contract that calls in all services? Do we need to accommodate a Navy under the Army contract? Do all services happen to buy under that one program, and you need to satisfy these various things? These things can get kind of detailed to come up with, okay, the contract calls for one thing, but in reality we need to satisfy other things. Who to contact? We should develop a contacts for the test program. The design, who's writing the procedure, how are we handling those situations, and how are we going to document the results of the testing. The abbreviations are used everywhere. The writing standards tell us to always create the abbreviation or the acronym. For example, IPR might be interposing relay as a definition, and we use it frequently. Those things that are used frequently, we need to put it in an abbreviation table so it can be looked up. Or those things that we think everybody knows, we should consider getting into this table. I got a valuable lesson in this one time doing a presentation in Brazil where I got used to dealing with terms that everybody knows, but everybody in the U.S. may know it, but in Brazil they didn't have a clue what half of them meant. And I didn't have an abbreviation table, so I got an immense amount of questions. So it's a good idea to put together something that has your common ones that you think might be the case. Be correct. If you're going to put in a K, a big K means Kelvin, temperature. A small K means kilo. Those are differences, and sometimes that's significant, especially when it's mixed. Like a large M is mega for a 10 to the 6 multiplier, or a small m could be meter. Could be other things, so you need to define them all. Something that you think is commonplace may not be to everybody. Let's talk about the EUT, the equipment under test. By the way, EUT, I just got a question on it. What do you mean EUT? And they didn't know what it meant in that application. Describe what it is. What does it do? Okay, or how are we using this? Somewhere you need to talk about your power requirements, the specifications. What are the parameters that this thing needs to have in order to perform its functions? Interfaces. How am I going to deal with interfaces? What's out there? What does it normally do? Any pertinent design information that could affect things. Like, for instance, you may have a paint finish that varies, and if we're doing tests with different paints, it could affect like sand and dust performance. So any of this pertinent information needs to be addressed into here. Not necessarily that there's a blue or a gray one, because that may not have anything to do with the paint quality or how it adheres, but the idea is if I'm doing something that says I'm going to use a conductive paint or something that's pertinent to the overall performance, need to do this. What's the production status? This is always a trip. Today I got a product in for an evaluation made from a 3D printer. Part of the evaluation is evaluating the chassis integrity. Can I accomplish any tests on the chassis integrity from a 3D printed version versus the actual molded part? I think not. So something needs to develop. What am I going to do this? Now, if I'm doing a test to do design guides to find out how good it needs to be, or just general specifics, it could be used. But we need to talk about what it is. What level of production are we evaluating, and what's our purpose? The installation, where it's used. Ships, vehicles, facilities, multiple things. Mounting. Is it secured? Bulkhead mounted? It's shock mounted? Welded in? This mounting trip really gets into a significant impact, especially when dealing with vibration and shock tests, because these mounts dampen or amplify a particular waveform or frequency, and so these need to be dealt with. You have a piece, your piece of equipment is like one item in an overall rack, and you hard bolt it to the rack. Does that mean the rack is shock mounted and you should do your test in a shock mounted rack? Well, if you do, then you got to decide, how am I going to manage the shock mounting weight ratio? If I've got a full rack that weighs 400 pounds and my piece is 40, I need to get the mounting to take care of that ratio, or the shock mounts to be proportional to the weight that's actually in test. So the evaluation has some merit. If I'm evaluating packaging as part of the overall program, get the real packaging. Or if I'm developing packages, I need a model to find out, have I got something that's reasonable. Classification. Security issues need to be dealt with. Okay, so don't treat this too lightly, because sometimes your handling of the product takes some special rules. In particular, ITAR is being called on a lot of military programs. We see this as a restriction, and we sometimes don't see the reasoning for it. But the idea is it's there, and remember that you have an obligation to be State Department registered if you're going to handle the ITAR program. How are you going to handle it? How are you going to maneuver it? Can I transport this thing by a vehicle? Does it require anything special about it? Locking it up, handling it, U.S. citizens only. By the way, is it feasible for an ITAR product to be viewed by foreign nationals? The answer is it can be if they're registered and into the system as being allowed to handle ITAR. The State Department has quite a few rules and regulations on that. So don't think it's an automatic no if you have a foreign national or dual citizenship within your laboratory. We need to define our references, or the applicable contract references. What version and revision is applicable? This gets us bit a lot of times because we document these items because we did a quote based on a revision 0 or 1, and suddenly the time to test comes and we're up revision 8. So we might have to update this and call for what the procedure is. When 810G is called out but a test comes out of F, can it be included? Well, technically it has trouble because you're not supposed to call under contract obsolete revisions. You're supposed to tailor it. But that doesn't mean it didn't happen. Or we're having to make something compatible with a previous version that was qualified under Mill Standard 810E, and our part to go in a vehicle that had the 810E qualification, we have to match that for the evaluation. So sometimes old standards do come into play. And remember the tasks, those tasks that are defined in the 404. We need to figure out, do we have that information? Now, a lot of you are going to look at this and say, well, I never see this kind of information, and that's true. That should have been dealt with in the contract definition. So the contract says you're going to do these following tests or analyses or whatever, and it got put into the contract so we don't get visual insight into the 404. But it should have been developed in making the contract happen. You need to look at the contract for items that incorporate scope and limitations. If the contract doesn't call it out or has deviations or limits, you need to be aware of those things. So this contract reference is kind of important. And not just a list of what the contract number is, but we need to address those specific things. They may not fit in the references paragraph, but we need to justify in whatever subject matter we're dealing with, the detailed procedure, that the contract made a limitation or a deviation. Some quality standards document. Are you an accredited laboratory? Do you require a laboratory? Do you need an INARTIS certified person to provide oversight? How are we coming up? Is it an ISO 17025 accredited laboratory to do the test? Something needs to be dealt with to identify how are we managing our quality. Our calibrations need to be addressed. Are we up to date on cals? All those things should be documented in our procedure. The test location should come about. Identify the test site, its capabilities. Does it have a certified Mill Standard 901 hammer? If it's not a certified hammer, then using it is not going to be allowed. So you need to get the certification in, or the end result will not be accepted. So if you're going to use an uncertified one, you put it in the procedure and get the approving authority to accept it, then you're allowed to do that. Who at this test site is the contact? Who's providing oversight or generic, or will put you in touch with the right person and can address topics, make decisions? The equipment instrumentation needs to be addressed and its calibration. Quite frankly, when I'm writing a procedure, I don't know what the calibration is, and it's not significant at the time other than we're going to use an instrument X with a current valid calibration by an ISO accredited laboratory. NIST traceable. And we say NIST because we think US, but let's think of national standard. If my qualification happens to be for the UK, would they accept the UK national body? Absolutely. So we need to look at the national standard for reference. The settings. How are we going to operate the equipment? How are we going to control things? For instance, where is the control for the vibration sensor? Is it on the unit, on the table, on the applied, at a given point? So these things need to be identified in the items. How are we going to set things and how are we going to control it? Responsibilities. Let's not take this too lightly. Who furnishes the equipment? Who furnishes support? The test and measurement. Who furnishes the fixtures? Is there government furnished equipment required? And will it be subject to the test? Does it risk potential damage because the government equipment has to be integrated? I just priced a job out where I'm testing a component. In order to do the test, the specific parameters required installation into the system on the vehicle at a test track that was built in 1933. Oh, it still exists, but so that's a real problem. So now I need to take the test article as a laboratory and have somebody, whoever is responsible, integrate it into the system and integrate that into the vehicle. Who's furnishing the vehicle? Who's responsible to get all those items? And that needs to be defined here. Oh, by the way, who's buying the gasoline for the vehicle? Those kinds of details needs to be left to not being assumed. Detail it into here. Who's responsible for what activities? Most of the time, a test laboratory likes to say that we will furnish the items to measure and control the environmental parameters for the test. Everything to make the unit work and support it is furnished by the customer. And the customer that you have for the laboratory may say, I'm going to have government furnish X, Y, and Z, and it could be defined into here. So as a part of the approval, you could have several lines of authority on who's responsible to do what. Who makes the decisions? That's a big responsibility. Who's deciding whether to go forward, halt the test because of an issue, etc.? Who accomplishes this performance verification? If I've got a person actively working on a project to control it, can he monitor the performance of the unit adequately? Like doing a vibration test. Can he look at the unit being vibrated and monitor all these parameters that may be required while controlling the vibration table? And who accomplishes the acceptance testing? Does the unit work right? Not necessarily just the performance, but is the unit going through any periodic full acceptance things, and who does that? Is that a handoff to the laboratory? Let's be specific because the assumptions are left to chance. So all of a sudden a 2-hour thing every time you turn around is being done and we don't know who's supposed to be doing it. So those things can be fairly significant in the overall scheme of things. You need to define those things. The test configuration, the build status. Is it a mock-up for something to develop in the design, or is it production ready for qualification? Production ready does not necessarily mean built by a production facility, but it should be built with production processes. How you accomplish bolting it together, any torque requirements, specifics for installation and things like that. How do we integrate everything into test fixtures, terminate the cables, or other types of interfaces? What kind of cables are we going to use for the test? Are they going to tolerate this? So help me, I was doing a temperature test and the cable melted away. The insulation on the cable started dripping into the bottom of the chamber because of the heat requirements. Any mechanical loads that may need to be dealt with. Remember, if you've got a hydraulic pump, letting it pump air is not the same kind of a test. It needs to be unloaded properly. And you need to provide protection of any support equipment. If I've got an item that's built into a product and it has to be built in for the test, is that support equipment that's hosting it part of the evaluation? Sometimes it's hard to avoid that. You build a circuit board for a device and it gets mounted into a host unit. A host unit is going to be subject to the test, not necessarily the printed circuit board on its own. So these definitions kind of are important to what's going on. How are you going to operate the unit? And are multiple modes applicable? It always amazes me that we fail to look at a radio transmitter in the transmit mode, where that's where all the heat develops, so we put it into a chamber for thermal stability and don't ever operate the transmit function. And what about these things that may have a duty cycle? Can I turn it off and on at the right duty cycle to evaluate it properly? Allow the heat to be cooled off because it never really operates properly. I seldom see these kind of things in most environmental plans, the duty cycle. A good designer will look at that because he knows he's going to burn his unit up, but the test lab may not know this. Like a fan that is turned on for thermal activity. Based on this temperature, the fan turns off or on. If that fan isn't operating during the thermal cycles, you burn up the unit without realizing your unit wasn't operating properly or you didn't know that. Can I do an integrated operation for test? In other words, have an automated cycle time where it transmits through one and it transmits to the second and then goes into receive for a certain amount of time. And we need to stay there long enough to get that cycle time accounted for. Some sort of dwell period. What do I need to do? Temperature shock test comes into mind. How long do I need to leave it at each one of the temperatures? Do I put a monitor on the unit to see that it has stabilized? Can I put a temperature monitor inside the unit to see that the overall stability is there, the thermal stability, or can I just simply say I'm going to allow it to be there for an next period of time? All these methods are approached, but you need to somehow define that. How often have you had a lack of pass-fail criteria being defined? Do I know exactly what's acceptable and not acceptable? I had a project a while back that had a solar radiation test for a unit inside a bag, but the bag wasn't part of the test. So I don't know exactly what the solar radiation difference in temperature was. So sometimes these get a little bit confused. And sometimes it's easier to do it the way they said it than to argue the case. Dealing with deviations is sometimes very difficult. Your pass-fail criteria needs to be something objective that I can measure, that I can know that yes or no it passes. Sometimes video quality comes into the scheme of things, and this becomes subjective, how good it is. So somewhere you need to sign that person X is going to decide acceptance. Tolerance. You can't have acceptance with zero tolerance. You can't measure that null set. So you need to have it's acceptable if it's this plus or minus 0.5% or 20% or whatever the tolerance is allowed. Do not forget in your EUT, in your test procedure, to put in the escape clauses. What constitutes a test success? And what happens when I have a failure? If it's relevant to the test, what do I do about it? Do I repeat the test? Or non-relevant, it was disassociated. Something went wrong because it was working fine when test B concluded, but when I set up for test C, it wasn't functioning, so something happened in the transition period. Like, for instance, I had to transport it to another location or building or shelter within the campus, and it didn't make it through the trip. Might not be relative to the test, but it's still a failure that you got to figure out how to get over there. And dealing with non-repeatable events, something that happened. You didn't catch the fact that a power glitch happened. It wasn't observed by whatever reason. Or it happened on the device but not on the control mechanisms. So we never got to see a non-repeated failure. So how long do we test till we say it wasn't real? How do we write it off? By the way, get into here too. Who approves these things? If I need to do a deviation to the procedure, who's the sign-off authority? How do I process it? Do I have to send it in for approval by the government agency? Or do I proceed and take a risk on it? These things need to be decided. How long do they have to turn it around? If I'm going to be sitting waiting on a response before I can proceed, somebody needs to say I'm going to make a decision within 5 days, 30 days, 6 years, whatever your reason is. Got a poll question up.
Whoops, sorry about that. Attendees, we'd like to ask you another question. How are test sequences selected? Please select one. Do benign tests first? do more severe tests first, Task 404 test list, or specified in MIL Standard 810G? We'll give you a few seconds to answer. And we have some answers coming in. And about the majority said for specified in MIL Standard 810G, with a few people answering also A and B. Back to you, Steve.
Okay. MIL Standard 810G has some guidance, but they're not very clear about it. They generally say you should do salt fog on something that isn't going to be tested for other things later because of the damage of it. And a few sequence things come out of 810 or general guidance. A lot of people look at doing the benign tests. They want to catch as much data as they can before they do the damage tests. Others look at severe tests first to find out where the problems lie before they continue. You get very little data when you do this kind of thing. But in general, you need to always consider your sequences based on the effects of ongoing evaluations. The idea is that the test article shouldn't be dealing with one test and one test only with a different sample for everything else. We need to examine, does heat cause immersion gaskets not to perform well? Do vibration tests cause cracks that leak during immersion or rain? Things that can one test contribute to the failure or success of a different test should be considered. And we need to build our test in that sequence. Should I do an evaluation on a before and after event? For example, a immersion or rain test, I might do it before dynamic testing like shock and vibration and etc. And then repeat it after to verify that there was no damage, that we know it was good, do the damage test, and then verify that it stayed good. Is that a requirement? So consider these things in developing your procedure and place a sequence order into the test procedure. Should be included every time. The Task 404 list may provide you some guidance on the sequencing, but in general they do not do that. Okay. Detailed procedures. The requirements are specific for the individual test methods. Those things that give you the step-by-step for doing the thermal cycling. Do I do thermal cycling mixed with other tests? Can I do a storage test, immediately go into operational test, switch over to the cold mode, do both of those in sequence, and then do altitude right behind it, or altitude with temperature? How about humidity mixtures? It happens in a lot of cases, but we need to develop this step-by-step, how long, what am I going to do for that test? Am I going to expose various sides to sand and dust exposure, or does it stay with one face only? If I've got an item that's installed in a vehicle for the sand environment and only the front face is exposed, why would I expose the rest of the unit to the sand when it's never going to get there in the real world? So we need to look at how the installation contributes to do this. That's why we ask so many questions early in the procedure as we've been discussing. Did I consider all these installation criteria? The specific test configuration details are placed in here. We have that generic test configuration that we say this is our normal, but then this test comes about and I've got to make a deviation to it. I need to put it in something. I need to have it the temperature elevated before I do something. So we need to consider those specific details. Do I need to have protective caps in place? How about connectors without them? Do they get exposed to salt fog, or do they have a protective cap? And if they contribute to a failure, how do I deal with those situations that, yeah, the normal thing is to do a protective cap? And those details would call out that, oh, I didn't have the right screws in it during the salt fog, so they all rusted and corroded and fell apart. But we're going to replace them with the screws, but we don't have to do the retest. Is that going to be supported? Quite frankly, it seldom is. They want to see some test data, or they wouldn't ask for the test to begin with. If they're going to accept just the parts specification, then they're not going to have it tested. So we need to look at what's going on for repeat tests. This test sequence, we just discussed test sequence, but relative to other methods, I personally like to put a table at the front of the detailed procedure to say, do these tests in this sequence. This is somewhat restrictive, but it sure does line up what we're doing, and everybody knows exactly what we're going to be faced with. You may need to put a rationale as to why you put them in that order. How are you going to handle an interruption during the test? Well, there's a lot of guidance in 810 on dealing with interruptions, and they deal with everything from the test item failure to your test chamber not performing, or you over-tested or under-tested, and it gives you some guidance in a lot of cases. You need to restate this and be very specific on how you're handling those things. The detailed procedure might involve calibration. For instance, I may need to pre-test a shock fixture before I put the unit in and expose it. So I may need to have a mass simulator to do a calibration and get all my settings and adjustments made prior to installing the test article for that. Go to the trouble in your procedure to write the calibration process too. Any settings and adjustments, how am I going to exactly do this thing? Don't leave it to chance. How am I going to collect measurement data? A lot of folks write procedures that still use handwritten data. Our technology is getting away from that rapidly. Allow for spreadsheets to reduce data where you plug in a number and the math is accomplished. I personally prefer these methods because once you validate your equations, you don't have math errors that creep in. All you got is keyboard entry errors. Do I need to print it and get a signature? Or can we do signatures by some other method, electronic signatures and approvals? You need to figure out what's going to be dealt with in your procedure. How am I going to record the data? What's my output going to be from this to support inclusion into the report? Don't forget that these things are important. You need to have the data collected. Any specific instrumentation that's required to monitor it, support equipment-wise, or to actually perform the test. You may need to have a multi-port thermocouple meter to get various temperatures throughout the product. But you also need to say that the measurement at X is the one I'm going to control from. Redefine your limits. Don't assume everybody knows that it's got to function during this test or after the test. You need to decide, what is it? Is it a storage non-operational with a performance check afterwards? Or do I have performance checks during? Is it different during the test versus immediately going through a full qualification afterwards? What parameters am I going to be dealt with? Data recordings. Our world of automation has allowed us to collect data that we didn't have any capability of doing a few years back. And we're growing that on a daily basis. Make use of these things. Your data recordings and your presentations should provide some detail here. Define how you're going to do this. What kind of parameters are going to be recorded and presented? The documents in general should convey the message. You need to discuss things in the terms that the reader will understand. Remember that the procedures are for test engineers and technicians. Speak to those people. Understand, use the terms that you're used to. Be thorough, provide some specific details, and make any deviations obvious. Quite frankly, if I deviate from what might be considered a normal or standard test, I might put it in bold and underline it and flag it in red and put a yellow highlighter on top of it. I want to point out that this in the lab. It may not be your normal event. Pay attention to this. I am doing a specific item. Be complete without being overly wordy. You don't need to make a bore them to death mode here, but you need to get the information is there so there's no ambiguity. You need to be very clear about what you want done. Make sure that the reviewer or approving authority can determine acceptability. Okay? If you can't get it through the approval phase, don't bother. And don't believe for a minute if somebody says the government's just going to review the procedure but it's not approved. If the government dislikes a procedure or fails to agree with how it's being done, you don't sell your product. So you will make a deviation. It's not just for information. It's going to have an influence on what you do. Use pictures, figures, charts. You need to apply this picture's worth of kiloword philosophy. Get all these things in place. I personally like to put examples of test outputs, data that I'm going to use for the reporting. Some reviewers do not like to see data samples into there because they say you've preloaded what the data is. Why? Well, because they've had submissions with the sample plot being shown. They take one out of the procedure and plug it into the report. It goes across, so they get to where they say, well, don't do that to force the real data to happen. I like to think that people are smarter than that, but apparently not in all cases. Requirements need to be specific for each one of the methods. You need to provide the technical rationale. If you've got choices, you need to define those things. Okay? Remember, this thing is a couple of things. This front end or the introduction and general details cover a lot of bases and a lot of information is contained there. But a lot of times the test engineer goes to the detailed procedure for the test that's being run, and that's all they see. So you might have to put acceptance criteria there also. Or a reminder, review the criteria in paragraph, whatever it is that you put it in, 6, 7, whatever paragraph you're using. If you follow an outline, as I've kind of described here, the odds are that you can get the acceptance of your procedures. Okay? I've used this kind of technique for years, and it tends to be there. Don't hesitate to be complete in your documentation. We're getting into a thing now of using electronic media where we abbreviate and code everything, and manuals and things assume that every user already knows what is being said. Approving officials seldom let assumptions happen. Provide the detail. Okay. That kind of goes through the presentation. I did finish a couple of minutes early. Next in our series is conducting the test, scheduled for August. So we'll get into more like how we're performing the test and things we're doing with this. And by all means, get the environmental test and design for information on the topic. Are there any questions?
Okay, thanks so much, Steve. We'd like to have a call for final questions. Attendees, please enter any last questions you may have in the navigation pane. There's a lot of information found on our website, www.environmentaltestanddesign.com. You can also email us at info@etdnews.com with specific needs, and we can direct you accordingly. Steve, here's a question for you. How are other standards associated with environmental testing integrated into the procedure?
Other standards associated with environmental testing? It's built in just like you would consider a given topic. For instance, if I've got Mill Standard 810 and DO 160, we may deal with each one of the tests independently or pushed together, like vibration is covered in both standards, and you may have to deal with both criteria where they do not integrate well. So you might just put vibration, DO 160, vibration, Mill Standard 810 in either order, depending on do you want to do the more benign first or the more aggressive first, and place them together, so integrating them so this test is accomplished together. The overall sequence of how you do the test are determined by contributing factors or things that you may accumulate a problem. So doing these tests in the same sequences should be kind of followed, unless the standard gives you direct guidance otherwise. Okay, does that kind of help?
Okay. Can analysis and inspection be included in the test procedure?
Test procedures normally limit to test, but it's not uncommon to have a procedure that involves everything. And it shouldn't be a test procedure, but then it should be an evaluation procedure just as a matter of context. But the idea is you can put any procedure that you want into your evaluation program. You can also integrate into one document tests that involve things other than environment. For instance, I recently did one document that had power quality testing, environmental testing, electrical safety testing, and EMC testing in one overall procedural document. Now the various people took each one of the sections and kind of did their own thing, but it made for a kind of a big document, but the reviewers got it all at one time. It kind of worked good for them.
Okay. What do you do without the detailed test plan, Task 404, to develop a procedure?
Could you repeat that?
Sure. What do you do without the detailed test plan, Task 404, to develop a procedure?
Oh, well, first thing I do is I leave the house, go out to the stable, find the fastest horse possible and get on it and ride away from the project. Now, the reality is you need to have some definition on what's going on. And without having Task 404 or something equivalent to it in the contract to tell you specifics, it's very difficult to develop an overall good test program. So you need to put this into the equation. Going into the test lab without having some sort of procedure or definitions is a recipe for fatality, because you walk in and nobody knows what they're supposed to do and what's acceptable and what's not acceptable, and things just like that. So avoid doing a no procedural document. Now, how formal is a procedure can be another topic of discussion, but something needs to be very specific. Quite frankly, I have done test procedures very informally through an email where it says, you wanted the temperature test done, give me the plus and minus temperatures and how long, and get an answer, and then another email, okay, now that you've done this, what do you want to do about this? And it feeds in one at a time. Now, that's just hard to do and wastes a lot of everybody's time. So you need to come up with something on an overall program. So stop going forward with the test until you define where you're going. If you don't, you go the wrong direction and you end up with problems. So some sort of procedure, plan, sequence, something needs to define what you're doing before you jump in the middle of it. Okay? Anything else?
That's it. Steve, thank you again for your time and expertise. Webinar attendees, if you have any more questions we didn't answer here, please send us an email at info@etdnews.com. A recording of this webinar will be available on our website, environmentaltestanddesign.com. We will also send a link to all participants shortly. Thank you for attending.
Thank you.